Before I can use Auditd, the first thing I have to do is install the package associated with Auditd using apt or yum. So in this case, because I'm on Debian, I'm going to use apt. So I'll say sudo apt install auditd. This is going to go ahead and install auditd and also set up a systemd service that I can use to manage auditd. The way auditd works is it allows us defenders to define a set of rules that specify what's going to get audited or what's going to get sent to this log. And that can be a lot of different things. So we can actually monitor file access or file changes. We can monitor changes to a directory or directory access. We can monitor a lot of different things. But one of the things that we can monitor that is potentially interesting for us in this case is we can monitor syscalls. Syscalls are a way of getting commands or code with limited privileges to interact with our machine or the kernel. I'm not really going to go into an in-depth explanation of what syscalls are and how they work, but basically what you need to know is whenever you're running a file on your Linux machine, the way it does that is using the execve syscall. So whenever you run a command, like for example, any command that isn't built in, there is a set of built-in commands that aren't run using a syscall. But whenever you run a command that isn't built into the terminal, like for example, I don't know, systemctl, it'll actually call execve and then it'll specify systemctl. So we can monitor these syscalls to actually get the commands that are being run on our machine. In auditd, we can do this with the auditctl command. So if I say sudo auditctl or auditctl, and I'm going to kind of cheat a little bit, and I'm going to go over back to my cheat sheet here, and I'm just going to copy this on over. So here's an example of how we would audit a syscall. So whenever that syscall is called, it's going to log it to auditd's log file, right? The syscall we actually want to monitor in this case is execve. And remember, execve gets called whenever we run a file on our Linux machine. And most of the commands that we have in Linux are in the form of files, right? And then the last thing I added here is this -k commands, and that just gives us a nice, easy way of searching it later on. So I'm calling this commands, and then later on when I try to search the log file, you'll notice that I just add the -k commands to my search, and then that'll search only for the logs related to commands. If that's the only thing you're logging, then this isn't necessary, but if you choose to use auditd for other things as well, such as logging directory access, then this can really come in handy to narrow down just looking at the commands specifically. The last thing I need to add here is, by default, there are 32-bit syscalls and 64-bit syscalls. And in this case, the syscall name is actually the same, but there are 32 and 64-bit versions, and we need to account for that. So I add this -f arch equals b32 for the 32-bit syscall. And then the second thing is, the second time I run this, I'm just going to switch this to 64, so we also monitor the 64-bit version of the syscall, right? Now that we've done this, all of the commands that we run are being stored in the audit log. Where is the audit log actually located? Well, if we go to var, it's actually in var log audit. We won't actually be able to go there as user, so we actually have to be root if we want to change directory into that directory, right? So I'm going to switch over to root. And then I'm going to go to var log audit. And then here we see this audit.log. So we can actually print out the contents of this audit.log. And you'll notice that it's monitoring all of our execve syscalls. So here you can see we have a bunch of logs that are associated with each of those syscalls. So what can we gain from these logs? Well, we can see, for example, here that I ran cat, right? And we can see that the first argument that I passed to cat was audit.log. So we can use this to kind of reconstruct the command that I ran, which was cat audit.log, right? In addition, we can see the directory that I was in when I ran this command. We can see the full path of the file that actually contained that command, right? We can see the capabilities. Remember, we talked about capabilities before. We can see the capabilities that are associated with this. And we can also see the user that ran this. I'm trying to see where we can see that. Oh, right here. We can see that the user ID was root and the group ID was root. So as you can see, this is another way of displaying all of the commands that everybody on our machine runs. If this log file, audit.log, gets cluttered, you can always search it using the ausearch utility. So if I say ausearch, and then I can say -k, remember before I said -k commands, that would allow us to narrow it down to just the logs that we're looking for. Again, I can say -k commands, and boom, I get the same sort of information that I would get if I was reading that log file with cat. You'll notice that there's a bunch of stuff in this log file that's kind of printed in an ugly format. So for example, this here is the time that command was run, but it's printed in a very ugly format. Fortunately, there's the -i flag provided with ausearch that's going to take a lot of those things that are in a really ugly format and print it in a pretty format. We also see some hex values here, for example, that would be better printed as ASCII, right? So -i is going to handle that all for us, and it's going to print everything much more nicely. So here we have this nice time. Here, when we're looking at the effective user ID, we can see that it's printed nicely, whereas it wasn't before. So if I actually wanted to read these logs, I can say ausearch -i -k commands, right? The next thing that I should mention is we configured this auditing using auditctl, or audit control. However, this will not survive a reboot. If we reboot a machine, we will lose all of the auditing all of the rules that we defined. In order to set rules so that they're persistent, or so that they survive across reboots, I'm going to have to actually add them to a rules file. So if I go to etc and audit, you can see in here we have our auditd.conf, where we can actually configure our auditd service, and we have this auditd.rules, this basic rules file. In addition, we have this rules.d directory that allows us to add our own custom rules. So if I go to rules.d, you see there are already some rules predefined for us here, but we can add our own by creating a new file and just giving it the extension .rules. So if I say nano commands.rules, all of the stuff that I typed in with auditctl, I can add to this file to make it persistent. So I'm going to take the same stuff that I typed in when I was using auditctl, and instead of using auditctl, I'm just going to include the flags by themselves. So we have one for monitoring 32-bit syscall, one for monitoring the 64-bit syscall. I'm going to go ahead and save that. And then I have to run a couple additional commands to get these changes to actually take effect. So first of all, we're going to check these rules with augenrules --check. And this tells us that we have created some additional rules And so we have to actually update or reload the rules. And so we can reload the rules with augen rules and then -- load. And so that's going to reload all of the rules, including the ones that we just created. And because we made changes to a configuration file just to play it safe, I always like to restart the service that's associated with this. So I'm going to say system control restart auditd to restart that service. And now, finally, all of those rules that we created are in effect. And if we were to reboot our machine, or if something were to happen and it shuts off and we have to restart it, or if the service restarts, we don't have to re-specify all those rules. Those rules are already there and they're going to survive those reboots. So, as I mentioned before, there are advantages and disadvantages to every auditing technique. So we talked about the disadvantages for the bash trap debug method, right, that I showed earlier. Well, this overcomes a lot of those disadvantages because it will log any sort of command that's run, whether or not it's run from a different shell or whether or not it's run from an interactive shell in the first place, right? So this is going to be a more comprehensive way of recording those commands that get run. The other thing is Auditd has a lot of built-in ways of making sure that that log file doesn't get too large on us and potentially overwhelm our system and exhaust its resources. So it's going to automatically trim that log file down for us after we get too many logs showing up, right? And so the method that I showed previously didn't actually do that. And so eventually that file would keep getting larger and larger and larger and larger and take up more and more space. And eventually would hog up a lot of space on our machine and we'd have to manually empty it, right? But Auditd handles that for us. The downside of Auditd is looking at those logs. This is really ugly to read compared to what we had before. So you're either going to have to dig through this and kind of figure out what's going on here. Maybe you can isolate it to just these execve calls. So I can grep for execve, and that's going to make it a little smaller, and then I can directly see what command is being run in order, right? So that makes that a little bit easier. But still, it's kind of ugly to read this log file. And so you may want to consider writing your own script for in a language like, for example, Python, that's going to take these logs and that's going to print them out in a much prettier way. So that's one of the disadvantages of using Auditd, is that the logs are really annoying to look at by themselves, and you might want to consider scripting out a way to more easily look at these logs. There are a lot of other things that you can do with Auditd that I highly encourage looking into. For example, if you know that you have a web server and your web files are in the var www HTML directory, you know that if an attacker wants to target you and wants to take down your web server, they're probably going to modify the files in the var www HTML directory, right? And so what you can do with Auditd is you can actually look for any sort of file-related events that occur within that directory. So you can audit for whenever files are read or whenever files are changed, and that can help you identify an attacker on your system early on. So there are a lot of different things you can do with these auditing tools, not just print out the commands. I covered printing out the commands because I feel like that's what's going to be most useful to you in a cyber defense competition, but you're certainly not limited to that. You're also not limited to the methods that I showed you. There are other ways of printing out all the commands that are being run on your machine, like, for example, using Snoopy, or, for example, using process accounting. And I recommend that you play around with it a little bit and take a look at different auditing techniques that you can use. Again, I provided you with that blog post that you can check out that talks about different kinds of auditing techniques and come up with some sort of method that works for you. Why did we go through this whole hassle to set up command auditing? Well, this allows us to see every command the attacker ran when they got into our machine. And if we can see the commands that the attacker ran when they got into our machine, we know how they escalated privileges, right? Or we know how they went from limited user to root. And that's very valuable information, because then seeing how they did that, we can go in and we can fix the associated privilege escalation vulnerability or lateral movement vulnerability.